If you do not care about the distant future, faraway lands, remote probabilities, you need not care about climate change. And I'm now going to talk about faraway lands. I've shown you this graph 2 weeks ago, where we looked at the impacts of climate change across different countries of the world, here ranked according to their per capita income in the year 2005. And what you see is that poorer countries are more vulnerable to climate change than richer countries who may even benefit. So climate change has very differential effects on different people. And the question is, how do you deal with this in a welfare analysis, in a cost-benefit analysis? Initially what people did was that they just estimated the impacts on different countries, expressed them in dollar terms, and added them all up. And that may be your natural tendency to do. This was done in the technical literature for a number of years, and then it was done in the context of the United Nations for the Intergovernmental Panel on Climate Change. And that caused a bit of a storm, because essentially when you do that, right, you're taking the impact, say, on health in all different countries in the world, and then measured, say, in the number of people dying prematurely, and then you estimate the price of these things. It's typically known as the value of a statistical life. It's essentially your willingness to pay to reduce the probability of dying prematurely. And you multiply the number of people dying prematurely times the value of a statistical life, you add them all up across the world. But of course, what you find is if you measure the value of statistical life in a country like the Netherlands, you would find that people are willing to pay 6-7 million euros, and you change the probability of these million people of dying prematurely by 1 in a million, and that is what you value. Then of course if you multiply the probability of 1 in a million by a million people, you find that one person statistically died. But what you find is that the value of statistical life in a country like the Netherlands is 6-7 million euros. But if you do the same estimation in a country like Nigeria, then you find a number that is closer to 70,000 euros. So essentially what you're saying is that you're much more concerned about somebody from the Netherlands dying than somebody from Nigeria dying. One is worth 70,000 and the other is worth 7 million. And if you try to say that during a UN meeting, you're in trouble, right? In deep trouble. How would you deal with this problem? Some people said, well, we should just use the same value everywhere, which is not what you want to do, because you cannot just say, this is an empirical measure. You cannot just say, screw the data, I'm going to impose my own numbers. That just doesn't work. And again, there's consistency issues here. But you could also say, well, we're actually going to stick to the numbers, but we're going to use a global average, say, value of statistical life, rather than country-specific averages, and we value things through that. Then you run into consistency problems. Why say that the global average is 1 million rather than 70 million or 70,000, or 7 million or 70,000? And essentially what you're saying to the government of the Netherlands, right, that if we're looking at a global problem like climate change, then you should value risks to health according to the global average value of statistical life. So somebody who dies because of climate change, let's go back to the example of investing in road safety versus investing in greenhouse gas emission reduction. What you say is that somebody who dies because of defective road safety is worth 7 million, and somebody who dies because of a bad climate is worth only 1 million. So a country like the Netherlands should do less about greenhouse gas emission reduction and more about road safety. Whereas if we go then to Nigeria, where we make the same argument, if you're dealing with a local problem, you should use the local value of statistical life. And if you're dealing with a global problem, you should use the global average value of statistical life. Then you're saying, well, somebody dying because of bad roads in Nigeria is worth 70,000, and somebody dying because of a bad climate in Nigeria is worth 1 million. So Nigeria should put all its money in greenhouse gas emission reduction and forget about road safety. That's not the answer you want to give, right? That's inconsistent and inequitable. Instead, what you should do, perhaps, is use different weights for different countries. And they are so-called equity weights. And they are defined as follows. And this follows the Fankhauser derivation. So we're interested in the global total impact measured in dollars. And what we have is the national damages also measured in dollars, DC. So you should make 3 transformations. First, you should wonder what is the welfare impact of these dollar values in this particular country. So you apply a Jacobian, right? You move from measuring things in dollars to measuring things in utility, and what you then need to do is multiply with the first partial derivative of utility to consumption, right? So this is measured in dollars, this is measured in utils per dollar, right? So now we have transformed things into the utility, which is sort of intuitive, right? Because if we just add up dollars, and essentially what we say is that $1 to a poor woman is the same as $1 to a rich woman. And if I take away $1 from your income, you feel bad, but not particularly bad because it's only $1, right? If you take away the dollar from somebody in South Sudan, right, and you take away 2 days' income from them, so they would feel a lot worse than you would. And similarly, if you take away $1 from Bill Gates, he probably would not even realize, right? Or Mark Zuckerberg nowadays, right? The richest guy. So this essentially says $1 to a poor woman is not the same as $1 to a rich woman. And that is this marginal utility that kicks in there. We're not there yet, right? Because we're interested in the global. So we need to assume some sort of global welfare function where we say, well, the change in utility in a particular country contributes to our global welfare in some way or another. So we need to do another Jacobian transformation and say, well, a change in the so this takes us from a change in the income in a particular country to the change in the utility in a particular country. Now we say the change in the utility in a particular country affects global welfare according to this particular transformation. That is the first partial derivative of the global welfare function to the utility in a particular country. If we sort of assume a utilitarian welfare function, this thing becomes 1, right? Because essentially we weigh utilities, but we don't say that people who are unhappy are more important than people who are happy, or vice versa. But you need to make that transformation. Now we have a problem, right? We want this thing in dollars. We started in dollars. We multiplied dollars by utils per dollar. So we're in utils. Then we multiplied it with welfare weights. So we have welfare per utils. So now the unit is global welfare units. We want the dollars, right? So we need to transform it back into dollars. And that is where the third transformation comes in, the third Jacobian comes in. That's WM, which, as you may have guessed, is measured in welfare units per dollar, because then everything cancels and we're back into dollar terms. The way to conceptualize this is what happens to global welfare is that if the global budget constraint is slackened by a little bit. What if a Martian would come along and give us an additional dollar, and we spread that dollar optimally across the people on the planet? What would that do to global welfare, right? That is the way to think about this. The M is for maximum, not for Martian. We slacken the budget. That's right. So that is your welfare weight. We multiply the nationally estimated damages with this thing, we add it all up to get to a global welfare one. This sounds horribly abstract. If we assume a utilitarian welfare function, that is, global welfare is just the sum of national welfares, and we assume a constant relative risk aversion utility function, then this abstract term becomes this particular term, where the equity rate, equals the world average income over the country-specific average income, or the country average income, raised to the rate of risk aversion, the curvature of the utility function, here for some reason epsilon rather than eta as it was before, and we multiply it. So intuitively, what does this say? That if the damage falls on a country where income is below the world average, then this term is greater than 1, right? Income is below the world average, so this becomes greater than 1. And we place more emphasis on impacts in that country. Whereas if the impact falls on a country that is richer than average, then this thing becomes smaller than 1, and we place less emphasis on monetary impacts in that country, right? That is what this says. It also says that if you have a linear utility function, no curvature, then your epsilon is 0, and if you raise something to the power of 0, we get 1. So then our equity weights are equal to 1, right? Everybody counts equally, or every dollar counts equally. And then what we say is that the global damage is just equal to the sum of the national damages. That is equivalent to assuming risk neutrality. Or, put it another way, equivalent to assuming that a dollar to a rich woman is the same as a dollar to a poor woman. So that is one way of justifying this. There is another way of justifying this, and there's definitely an implication of all of this. So assume, just for sanity, that epsilon equals 1. Then we have that the equity rate is the global average income over national average income. We use that as an equity weight for our national impacts. The national impacts are, of course, the quantity of national impacts times the price of the national impacts, right? Think back to the example of the number of people dying prematurely and the value of a statistical life. We can assume that the value of a statistical life depends on income, right? And let's just assume that we have an income elasticity of 1 there. And then we can say we take the global average value of statistical life, here given as V0 rather than VW for whatever reason, times, of course, the income ratio, right? So this is the global average, and then for other countries, you multiply it with the ratio of income of country to the world. The income elasticity is 1. So this term here equals this term. And then we have the fortunate situation that YC cancels against YC and YW against YW. And we valued all the impacts at the global average. And this was actually one of the things that I suggested to solve this problem, right? We take the national quantities with a global price. Now this is only justified if the curvature of the utility function equals the income elasticity. And the curvature of your utility function and your income elasticity are related to each other, as you may recall from micro, but they are not the same. There is no reason whatsoever to assume that in general your income elasticity is equal to the curvature of your utility function. So this is a very special case. It can pop up, but it definitely would be unexpected and perhaps exciting if it does. Equity, relatively straightforward. Now I'm going to put everything back together again, right? And the question is, what should the Pigou tax be? And I'm going to show you 4 graphs that will tell you how these things hang together, which is more important. The numbers that they're always looking at is the social cost of carbon. So this is the intensity of climate policy if you want to maximize welfare. The different colors denote different pure rates of time preference. So in blue you're looking at 2%, in red you're looking at 3%, in green you're looking at 1%. And then on the horizontal axis, you're always looking at the rate of risk aversion, the curvature of the utility fund. No equity, no uncertainty concerns. So the only thing that the rate of risk aversion does is it affects the discount rate through the Ramsey rule. Right? The Ramsey rule is rho plus eta g. This is eta. And the different colors are the different rows. So what do you have? Well, for a given eta and a given g, let's just look here. If we have a lower discount rate, we have a higher social cost of carbon. Right? The more we care about the future, the more we care about climate change, the higher the social cost of carbon, the lower the discount rate. Right? So that is exactly what you would expect. The green line falls above the blue line, falls above the red line. And then if we increase the rate of risk aversion, we increase the curvature of the utility function, we increase the monetary discount rate through the Ramsey rule, and your social cost of carbon comes down. Now introduce equity. The rate of risk aversion, the curvature of the utility function, now fulfills two roles. It still is an important parameter in the Ramsey rule, but it also determines how much weight do we place on the plight of the poor people. And the trade-off there is the same, right? We sort of looked at the Ramsey rule as making a trade-off between your poor self today versus a richer self tomorrow. Now we're also doing that instantaneously, poor people here versus rich people there, right? In both cases it's driven by the curvature of the utility function, and it's the same parameter. So the rate of risk, the pure rate of time preference, still the same. If it goes down, the social cost of carbon goes up. The curvature of the utility function, the rate of risk aversion, now fulfills a dual role, right? So here what we see is your rate of risk aversion goes up, your discount rate goes up, your monetary discount rate goes up, and social cost of carbon comes down. But what you see is that you actually start bending upwards in the end, which is because it's this bit for a relatively low pure rate of time preference, you're putting a lot of emphasis on what is going on in very poor countries. And that is why it's going up. And then the red curve, it actually goes below zero. And we actually start advocating for a carbon subsidy rather than a carbon tax. And the reason for that is, well, you use a high pure rate of time preference, so you're really only interested in the short run. In the short run, putting additional CO2 in the atmosphere will increase CO2 fertilization, will increase agricultural production, which is particularly beneficial to people who depend a lot on agricultural production, that is the poor. So here you're actually emphasizing the positive impacts of CO2 fertilization to the poor, and if that is your case, then you're really only interested in the short run, because the Ramsey rule tells you we discount the far future. Your pure rate of time preference tells you we are discounting the far future, but you're also saying, well, we should really care about what's happening in the short run to agriculture in poor countries, which is positive if we put more CO2 in the atmosphere. So we should be subsidizing carbon rather than taxing carbon. So that is if we add equity but ignore uncertainty. Now ignore equity but look at uncertainty. This is perhaps more what you expect, right? So still the green falls above the blue, falls above the red, right? Pure rate of time preference did not change its role. If we increase the rate of risk aversion, then we put more emphasis on the present relative to the future, so the social cost of carbon falls. But then if the utility function becomes very curved, we start putting a lot of weight on what is going on in the tails of the distribution, and the uncertainty is asymmetric, and we put a lot of emphasis there. The certainty equivalent starts deviating strongly from the expectation, and we see the impacts go up quite steeply. And here you actually see that it goes well above 1,000. So at first we de-emphasize the future, and that is the effect that dominates. And then we start emphasizing the tails. and that begins to dominate. And then if we put equity back into the mix, this picture results, which, as you immediately notice, is qualitatively more like this one than like that one. So the implication here is that concerns about uncertainty are actually more important than concerns about equity, numerically, right? Conceptually, it's not necessarily the case. The qualitative difference that you see is that, yes, you still pay a lot of emphasis on the short-run benefits of carbon dioxide fertilization on the poor, but there's also a lot of downside risks to the poor, and they actually outweigh the sort of certain benefits, and the positive and the possible negatives actually far dominate these ones here. So the uncertainty for the poor is actually much more asymmetric than the uncertainty for the rich, and that is why the red line also starts asymptoting upwards.
So, for the next figure, in the first stage you're concerned about uncertainty is larger than equity, and later you think it's concerned equity is larger than uncertainty?
Yeah, but only for this one here, right? Only for the red curve that is the case. So that is the emphasis of the short run versus the long run, right? Because then we have a high pure rate of time. So what do we learn from this, right? It is complicated, right? You cannot just say, oh, if we make the utility function more curved, then things go up or things go down. That just does not follow. You need to think very carefully through all the things that go into the analysis. So that is the first thing that we learn. Second thing, nobody protested. The second thing that we learn is that there is a bit of a research agenda there, or here. And I sort of assume that the curvature of the utility function is the same over time as it is over people, as it is over risk, which is a peculiar assumption, right? If you make an evaluation of your poor self versus your poor current self versus a richer future self, that trade-off is somehow governed in the same way as that you would make decisions about yourself in this state of the world versus yourself in that state of the world, but both at the same future time, and that you would again make the same trade-off as if these poorer and richer people are not yourself but are different people, you would still make the same trade-off. Now, writing down a utility function that curves differently in the different aggregations is still a bit of a challenge, right? So those of you who are theoretically inclined economists, there is some work to be done. And the separation between risk aversion and time preference has been done by Epstein, Zinn, Weil, and this other guy. But to also then tie that into inequity aversion is still a bit of a challenge, and particularly if you want to take into account that perhaps we think differently about inequity aversion between people of the same group and between different groups of people. So there is a bit of work to be done, but what is clear is that you should be fairly careful here. The other thing that is clear is that your pure rate of time preference is essentially a base parameter, right? It tells you how much do you care about the future relative to today. And the rate of risk aversion is essentially a phased parameter. It tells you how curved is your utility function, but it's your utility function, it's not my utility function. You decide on what your utility function is, not me, right? So these are essentially phased parameters. And depending on what parameters you pick, you can defend a carbon subsidy, a small one, but you can also defend a very large carbon tax, right? You can justify small climate policy and big climate policy and very big climate policy, depending on what parameter you pick, right? So you can turn the question around and say, I favor a very strong climate policy, so therefore my pure rate of time preference is 1 and my rate of risk aversion is 2.25, right? Because I think that the carbon tax should be $1,000 per ton of CO2. Right? You can invert the problem in that way. We should be very, very careful. Where do we get these parameters from? And that's what I'm going to talk about after the break. There's essentially two ways of doing this. One is to follow some sort of ethical guidance. I have here Jesus, who actually was pretty silent on most of these things. Didn't say much about time preference, didn't say much about risk aversion, but did have a lot to say about caring for others, right? Lord Stern had a lot to say about caring for the future. Lady Gaga has lots to say about all sorts of everything. And you can say, well, I'm going to read their writings. Muhammad also had things to say about these matters, right? Thomas Aquinas had things to say about these matters. You can take their guidance and follow them. That is one way. Or you can make up your own mind, right? That's not one. That is a very paternalistic way of reasoning, right? We follow an authority figure and we trust their judgments and we pick their parameters. You could also just try and measure these things in a sort of a more democratic way, and you say, what would the average person in my electorate or on the planet think about these things, and perhaps we should follow that guidance. That's what I'm going to talk about after the break. How would you actually measure these things? And I've emphasized now a number of times already, whatever you do there, you have to be consistent, right? So you cannot say, I am risk averse in climate, but risk loving in trade. That is just nonsense. You cannot say, I care about the future of climate, but I do not care about the future of pensions. That is just a silly thing to say. So you have to be fairly careful there. And I've again put the Schelling statement there, right? If you reveal so much care for what's happening in Africa through your environmental policies, through your choices about greenhouse gas emission reduction, why have we closed our borders for them, right? And not just for them, through our migration policies, but also through our trade policies for their main products, right? And it's just not consistent. And if you say we should care about the Africans because of what climate change would do to Africa, then perhaps the implication is that we should also reduce our agricultural tariffs and start buying their products. I actually think there's a very good reason to that, a very good case for doing so. There's nothing to do with climate, but you should be consistent there, right? You should be consistent there.